Welcome back from an ad break. So now we're going to be looking at our next concept, which is now the reactants and the products. And we know that these things are found in a chemical reaction. We now need to know then how do we then model them to make a chemical equation. So firstly, to model these reactions, we use names of the elements, the modeling atoms, and we're also using the chemical formulas. And then we are going to take all of these things and bond them together and form a chemical equation. So we're going to take the name of an element, or sometimes take them with the modeling atoms, and even take the chemical formulas of these particular things and mold them together and form a chemical equation. Now, what is a chemical equation, you may be asking yourself? That is an expression that uses symbols, and these symbols are showing the relationship between the starting substances. Remember that the starting substances, those are the reactants, the ones that participate in a chemical reaction. So it shows the relationship between the starting substances and the substances that are produced by a chemical reaction. So the substances which are produced by a chemical reaction, we know them to be products. Those, they come at the end of the reaction. The starting substance, they need to break the existing bonds and form new bonds, and then that's only then that you can form the products, which are the substances that are produced by a chemical reaction. So for an example here, we have this particular example of CH4 plus O2. We have the modeling atoms here to show that the yellow substances are showing the atoms of hydrogen, the H. And then the red substance there at the center, it is showing the model of an atom of C. Then we have these two that are chemically bonded. So even these ones, they are chemically bonded. Each one of those hydrogen atoms is chemically bonded to the C atom. Now these two particular atoms, or the oxygen atoms, are chemically bonded together to form the oxygen molecule, and that is a diatomic molecule. Now, these bonds that are bonded, that are within this CH4 and within this O2, they are going to break. And once they break, it allows for the rearrangement of the atoms. So now, what's going to happen is that this particular red substance there, being the C, it is now going to be bonding with the O in between. So it's going to be in between the two oxygen atoms. So the arrangement of the particles, or the arrangement of the atoms, has changed. So we now have the CO2 as our product, and also having our H2O as the product. So to begin the reaction, we had the methane gas, which is the CH4. Remember, methane is the name, as we have said, we're using the name. And then the CH4, that's now going to be showing the chemical formula. And then these pictures that we're seeing here, those are showing the modeling atoms that are going to be at the beginning of the reaction, even after the reaction. Remember that the arrow shows that the reactants have reacted to form this thing. So they are showing or pointing away from the reactants. Now, if we also to look at this example, that we are going to react carbon, that is going to react with oxygen, and that is going to be forming our carbon dioxide. So to start, the name, modeling atom, and the formula. So we start with the name carbon. That is going to react with oxygen. Now the modeling atoms of those reactants, remember, if they are written before the arrow, on the left-hand side of the arrow, they are known as the reactants. If they are written on the right-hand side of the arrow or after the arrow, they are known as our products. So these two reactants that we have here, they have a chemical symbol of C, and then oxygen has a chemical formula of O2 because it is a diatomic molecule. Now the arrangement of these particular substances is going to change to form the carbon dioxide, which has a chemical formula of CO2, to show that this bond, this compound was formed by the combination or by the chemical bond of carbon and the oxygen. Now we're seeing that the reactants that we have on this reaction are the C and the O2. Those two things are going to combine together, chemically bond together to form the product being the CO2. That is our carbon dioxide, what we breathe out. Right. What is now entailed in a chemical reaction? and what is entailed in a chemical formula, and what are those reactants and the products. So a chemical formula uses chemical symbols. We know that a chemical formula needs to use the chemical symbols, and we also know that these chemical symbols that we're talking about, they are found in the periodic table. And a combination of those symbols from the periodic table, they form a compound in a certain or fixed ratio. Now, a chemical formula uses chemical symbols and numbers to represent a given substance. Now, those numbers that are being talked about here, those ones are showing the ratio. For instance, if we are to look at this particular compound here, the H2O. Now, this is showing that this ratio is that of 2 hydrogen atoms with 1 oxygen atom. So that the ratio is fixed for water. You will never find a water molecule having H3O or H4O. It is always H2O. It is fixed. Each compound has its own fixed ratio. Now, the chemical symbol in a formula tells us what elements make up the substance. So this particular formula here tells us that we have 2 hydrogen atoms and 1 oxygen atom. So this particular substance of water is made up of those 2 things, 2 hydrogen atoms and 1 oxygen atom. The number written below and to the right of a chemical symbols, those ones are called subscripts. So which numbers are we talking about here? We're talking about this number here that is written below and to the right of the chemical symbol. The 2, and these 2. So those ones are our subscripts. So what do they help us with? Now, those numbers, they are telling us how many of each atom are in a molecule. Just like we have said, in this molecule of water, we have 2 hydrogen atoms and 1 oxygen atom, because there's no number given or there's no number written on the right-hand side and below the chemical symbol. That means that it is 1. Lastly, any time atoms separate from each other and recombine into different combinations of atoms, we say that a chemical reaction has occurred. So when atoms are rearranging and also coming back together to form something totally new, we can then say that in that particular case, a chemical reaction has taken place. Now, we have examples of chemical reactions that are taking place. We are starting again with the CH4 that is going to bond with the O2, which is going to produce the CO2 and the H2O. Remember the numbers written at below and to the right of a chemical symbol, and they are known as subscripts, and they denote the number of atoms that are in that particular molecule. In this one, we have 4 atoms of hydrogen that are chemically bonded to 1 atom of carbon. Then on this one here, we have 2 atoms of oxygen chemically bonded to 1 atom of carbon. So as we can see, we started with a bond between carbon and hydrogen. But at the end of the reaction, the arrangement has changed. We now have the bond between carbon and oxygen, which is totally different from what you started with, which was the carbon and the hydrogen. Now, in a chemical reaction, what happens? The existing bonds are breaking, and as we can see, the bond between this particular molecule is going to break, and there's going to be new bonds which is going to be formed from the breaking of those bonds. So the substances which are formed after this bond has broken, that's going to be our products, because those are formed after a reaction has taken place. And remember, the reactants are written on the left-hand side, products are written on the right-hand side. And they are separated by an arrow to show that this is reacting to form something new. Now, moving on to our next item, which is now the useful chemical reactions that we're going to be talking about here. What are they? What do they help us with? And how do we know that this reaction is useful to us? Number 1, indigenous knowledge is the traditional knowledge that people have gathered over many years. So we're going to be talking about this indigenous knowledge that people have gathered over many years, and they're using that knowledge to form something from the indigenous practices. So this knowledge includes useful chemical reactions for food preparation. Now, which food preparation are we talking about? We'll see. Now, to carry out these chemical reactions in food preparations, they are using yeast and bacteria. So these are going to be useful in these particular reactions because they're going to be helping with the fermentation of the reactants to form something new. We'll see how that happens. For example, when they're making a sour milk and umqombothi, they are going to be making use of the yeast, which is going to speed up the chemical reaction. So basically, the yeast and the bacteria are used as a catalyst in those particular reactions. Then a catalyst, it is a substance that speeds up the chemical reaction. So now, in this case, the yeast and the bacteria are used as a catalyst, and as we have said that a catalyst, it is a substance that speeds up the chemical reaction, and then it doesn't take part in the chemical reaction. So for instance, we have now that they have taken a milk and used bacteria from the milk to make it sour, and also used certain ingredients and also added to the yeast to speed up the chemical reaction to make umqombothi, which is the traditional beer, the Zulu traditional beer. Now, the souring of milk, how does that happen? What do they use and how is it formed? Now, this is a process that turns milk sugar into milk acid. Now, how do they achieve this particular reaction? They are achieving this reaction by making use of the bacteria for the fermentation process. Now, so basically, they are taking that milk sugar with the bacteria in it, and then that is going to form into milk acid, which is known as the lactic acid. So our next useful chemical reaction is fermentation. What is fermentation? So that is a process that turns sugar into alcohol and carbon dioxide, and this is done with the help of yeast as a catalyst. Remember, catalyst, substance that speeds up the chemical reaction. So that particular reaction can be represented using chemical formulae. Now we have a glucose, which is going to produce the ethanol, that is our alcohol, and the carbon dioxide. So using the chemical symbols for that particular reaction, we have this particular reaction here, C6H12O6, that is going to produce the 2C2H5OH plus the 2CO2. So this, remember that this is the carbon dioxide that we are excreting when we are breathing in and out. We are breathing out carbon dioxide. However, we also need to know that even though we are breathing out carbon dioxide, this process of fermentation doesn't only produce the unwanted products, because we are breathing out carbon dioxide means we don't want it. So therefore, this particular reaction doesn't only produce the unwanted products. The things that we eat as well, the yogurt, the buttermilk, and cheese, they are all fermented milk products. So that particular reaction of fermentation can also produce these things that we eat. It's not only the unwanted products. Now, in these examples, the fermentation process creates acids that gives this food a sour taste. So the fermentation process is going to create acid that is going to give the food that we eat that sour taste, right? Now, when does it happen? What are the favorable conditions for this process to happen? Number one, there must be optimum temperature. There shouldn't be oxygen in that particular reaction, and it must be happening in an aqueous environment, meaning in a solution. And then the reaction must be slightly acidic. So the pH must be slightly acidic, meaning that it needs to be just less than 7. Now, however, the fermentation cannot continue if, so these are the favorable conditions, but then if one of this is happening, that process is going to stop. Now, when the concentration of ethanol, which is alcohol, is high, so once the concentration of alcohol is high, then this reaction is going to stop. And also, once the pH falls below 6, this particular reaction, the fermentation reaction, it is going to stop. So learners, we have looked at the useful reactions, we have looked at the reactants and the products, we have also looked at the chemical reaction, what is entailed in a chemical reaction, looked at the arrows, the plus signs that are within a chemical equation. For me, this was a fun lesson. I hope you had as much fun as I did. Until next time, bye.